Good morning everybody. I am Professor Rutuja Kadam from Symbiosis Institute of Technology, Pune. Today I will be covering an important topic in computer organization subject, that is flag registers of 8086. Now before starting with the flag registers of 8086, let us look into the basics of 8086. So what is a 8086? It is a 16-bit microprocessor. And flag register is the part of the execution unit of 8086. So it is a 16-bit register with each bit corresponding to a flip-flop. Now what is a flag? Flag is a 1-bit flip-flop which is able to store either 1 or 0 as its state. It also indicates some conditions produced by the execution of an instruction. So as I have told you, flag registers of 8086 is of 16 bits starting from 0 to 15. Out of these 16 bits, 9 flags are used and 7 flags are unused. If you see here U, this stands for unused, or it could also be called as undefined. Now these are used ones, CF, PF, AF, likewise. Out of these 9 flags, again they are further divided into status flags and control flags. These are 8, 9 and 10 are control flags, and the remaining 0, 2, 4, 6, 7 and 11 are status flags. Now let us look into this one by one. So carry flag. So carry flag, I'll be showing this with an example. So carry flag is set to 1 when the result contains a carry. If you see an example over here, we are adding two numbers 111 and 100. If you perform addition, it is 1 1 1 and 1 plus 1 0 with 1 carry. Whenever a carry is generated out of the MSB, then the carry flag will be set. Where set means we will put the value of carry flag is equal to 1. The second flag is parity flag. Now this parity flag, if the result is having even number of ones in it, then it is set, otherwise it is reset. Now let us see this with one example. So here we are adding two numbers. The addition of these two numbers is 1 1 1 1. The result is having even number of ones. So whenever the result is having even number of ones, parity flag will be set to 1. Then let us go to the auxiliary carry flag. This is the auxiliary carry flag. Now the auxiliary carry flag says that if there is a carry generated from this lower nibble to the upper nibble, that is if the carry is generated from B3 bit to B4 bit, then this auxiliary carry flag will be set. Then we have ZF. ZF stands for zero flag. If the result is 0, then the flag will be set to 0, else it will be reset. Then next is SF. SF stands for sign flag. Now what do you mean by sign flag? So if the result is negative, then the sign flag will be set to 1. If the result is positive, then it is 0. Then the 11th bit is OF. OF stands for overflow flag. Now overflow flag. So here if you look at the example of overflow flag, it is 1 1 1 1. We are adding it with 1 0 0 0. Both the numbers are of 4 bits. So actually the answer expected is of 4 bits only. But then if you add these two numbers, we get the result as 1 1 1 0 and 1. 1 is the carry, which is overflow, because the answer that is coming is of 5 bits. So this bit is a overflow bit, and whenever an overflow is generated, overflow flag will be set to 1. Now we have completed with the 6 flags in status signals. Now we will start with the 3 remaining flags of control signals, which is TF, IF and DF. TF stands for trap flag, IF stands for interrupt flag and DF stands for direction flag. Now this TF means trap flag. So in trap flag, if you want to perform execution of the procedure or a program step by step, then it will be set to 1. Or if we want to execute the program at once, then it will be set to 0. Then comes interrupt flag. Now this interrupt flag, there are certain maskable and non-maskable interrupts in the microprocessor. If you want to enable that interrupts, then we have to set it to 1. Else, if we want to disable the interrupts, we have to set it to 0. Then comes direction flag. So basically this direction flag is used for string manipulation. So if we want to process the string from lowest byte to highest byte, then the direction flag should be set to 0. And if you want to process the string from highest byte to lowest byte, then the direction flag should be set to 1. So this was all about the flag registers of 8086. I hope you have understood. Thank you.